So we're going to be talking about infrastructure as code tonight. We're going to have two talks. The second one is going to be, I think, build upon a number of the things that I introduce. At least I hope so. And it's going to be my pleasure to introduce you to the Azure native tool for infrastructure as code, which are ARM templates. So in case you are wondering who I am, my name is Henry Been. I'm a developer and architect. I actually live on a small island called Texel. So I travel up and down to Amsterdam every week for a couple of days to work here, and really happy to be here tonight. So my details are just on the screen. Reach out to me if you have any questions. I don't really mind. If it's a really long or really boring question, I just won't reply. And the point that I want to make today, and I hope that I can show you to accomplish, is this portal, this Azure portal that we all know, is how we can get rid of it. So I see at least one smiley face. So hopefully tonight we will see the portal only to help us get rid of it actually. So infrastructure as code, a very, very, very quick introduction. This is basically what we're going to do for 45 minutes. We're going to write JSON. So there are pros and there are cons according to some people, but this is what we're going to do. We're going to write JSON and we're going to transform it into Azure infrastructure. That's the whole point of tonight. So why do we want to do that? Well, the reason is that things in the portal are very, very difficult to review. If I have to go into the portal and I have to check if the configuration of something as simple as a storage account is correct, there are so many options I have to check, it is very unlikely I see everything. And even worse, once I have done that and I say, this looks good, somebody's going to duplicate, or at least try to duplicate, that thing to, I don't know, an acceptance environment, where I have to do the same checking. And then we try to promote the settings to production and somebody makes a mistake. And all the testing and all the trialing, all the verification that we have done up to that point is useless because we are not reproducing the same thing. So the other part, or the big benefit is that we can take this thing and we can reproduce it to multiple environments. We can do continuous deployment of our infrastructure instead of just our code. And that really gives us three things. First of all, it will give us a lot of speed. So apparently not very much longer 130, but 100 at least here in the Netherlands. It's kph, by the way, miles for the recording, no miles. But if we practice infrastructure as code, and I need to make a simple change in my infrastructure, I change the file and it will propagate to production automatically, opposed to manually clicking. It gives us a lot of precision and consistency. If there are people into archery or shooting, consistency is when you put a lot of holes close together, and precision is when they are actually in the middle instead of all in the top left or all in the top right. So we get precisely what we describe repeatedly, and we get it consistently every single time. And it gives us repeatability. It gives us a guarantee that we can reproduce the same environment with the same configuration over and over again if we want to. Okay, so I hope I've solved it, but you might be wondering, what do I get out of this? So I thought I'd take a picture of a kitten, because we all love kittens, and then say, that's not what we're going to do with our infrastructure. We're not going to cuddle it. We're not going to like it. We're going to treat it as cattle. We're going to create our infrastructure, I don't know, a virtual machine, and then we're going to disregard it again, because we have infrastructure as code. As soon as we need it, we spin it up again. And that allows us to do things like environment on demand. If I want to run my tests, I create the infrastructure I need for running my tests, run my tests, and tear the whole thing down again, maybe within 20 minutes, automatically, every time again. So I will now get one of the most important principles of testing also on my infrastructure. I have a test set up that guarantees that my tests will always have the same starting point, even if I'm using databases or stuff that touches the local file system. And another thing that I can do is I can extend that to even my production environment and do things like blue-green deployments. not reusing the same virtual machines, but creating virtual machines, deploying my compute, switching over to the new environment, wait 30 minutes and just throw the whole stuff that I had away. These are things that we can easily do when we practice infrastructure as code. Now I hope you're really sold. We're going to do that using the Azure Resource Manager. So the Azure Resource Manager is like a unified API on top of all the services within Azure. It's the thing that you interact with indirectly when using the portal, and a thing that you can also interact directly with using REST APIs. But next to those REST APIs, you can interact with it using ARM templates. And we're going to spend most of our time exploring those. A quick recap of things that we probably know. But let me check. Who is using Azure here? Who is experienced with Azure? All of, okay. So this is probably a recap. When we're talking about things in Azure, everything is a resource, up to the individual IP address or a NIC or whatever, a dashboard, an alert rule. And we can interact with those things in two ways, the management plane and the data plane. So the data plane is probably what we as developers used to interact with before we had the cloud. We're going to connect to a database, do a query, and then get results. The management plane is the thing that, I don't know, IT operators used to do. The person that you call and say, can I please get a database? And then you wait 6 weeks, and then you had it. Well, that person is kind of replaced by the management plane. This is the set of operations in Azure that you use to create resources, delete resources, scale them up, manage who can edit them, etc. And we're going to be talking about the management plane only tonight. Continuing the recap. In Azure we have resources. They can be grouped in resource groups, which in turn can be grouped into subscriptions, which is where the credit card lives. And those things can be grouped into management groups, into management groups, into management groups, 6 layers deep. Another way for looking at the grouping of our resources is by the resource provider. So this is like a logical group, for example, of all the resources that I need for one application or application component. Here I have another grouping of resources by what they are. For example, all SQL databases or all virtual machines. They are all governed by a small Sorry, this takes all of my concentration, so I can talk. Where was I? Yeah, so we have resources provider that govern those things. We talk to a resource provider and say, I want a SQL database. And a few minutes later, I've got it. And that resource provider is responsible for keeping the thing up, making the replicas, and all other things that I want to do with the database when it comes to management operations. Now, just think that these things are more or less aligned to a team within Azure. Learn 180 different APIs. So on top of that, I can. Well, so there are different ways of interacting. Portal. Templates, and finally directly through the REST API, bypassing all of these access systems. Okay, so this has probably been a lot of recap. Hopefully we're going to get a little bit more interesting right now, so I'm going to slow down a little bit and try to stop squeezing 55 minutes into 45. If we take all this knowledge that we now have, we can think about the identity of a resource. Every resource can be addressed using a new URL like this: management.azure.com/subscriptions /your subscription ID /your resource group, name of the resource group, /providers, then the name of the provider, which is a thing you might have seen already. It's Microsoft.SQL or Microsoft.Compute, those kind of things. Then slash the resource type, which is, for example, servers or databases when it comes to Microsoft.SQL, and then the name of the resource. And finally, you can actually call this URL on any of your resources. You have to specify the version of the API that you want to hit, and then you get an actual result. There's a thing called nested resources. For example, a SQL database is on a SQL server, so the full address of that database is made up of including the name of the server as well. Bless you.
Thank you.
Now if I call an API like this, subscriptions and the name of the resource group, then a provider, in this case Microsoft.Service Bus, which is the one that we use to create a service bus namespace, specify a name and the API version, I can just post a little bit of JSON describing the service bus namespace that I want. And once I have done this, and I've waited like 30, maybe 60 seconds, and now I do a get on that same URL, I will get another JSON document describing the resource that it actually is. So now I get a number of properties that I didn't specify, like when it was created or last updated, in return. This way you can manage your Azure resources as well. Now at this point you might be thinking, this is a lot of URLs, this is a lot of JSON, how is this going to work out for me when I want to really work with this? So there is a reference for all these things, for all the resource providers, for all the resource types, and for all the individual properties of all the individual resources. So you can find it actually here, but I'm a big fan of another approach, which is like binging it with Google. So if you go here, you can find a complete reference of all the things within Azure. So let's take, I don't know, SQL, and then go to all resources, and let's find the server, choose an API version, and now I can find the name of the resource provider, the name of the resource type, an example document, and a very detailed specification of all the properties involved. Awesome. So we have a REST API, we have a description, and we can interact with it. However, it is not very handy to work with. So there are more convenient ways. We can use PowerShell. These are all commandlets that you probably know, and are built on top of this API. Same goes for the CLI. I think the CLI is winning from PowerShell. It's more modern, more sexy, and more appealing to a lot of people. But you can also do it from your code. If you are writing C# and you are writing code that's going to create a database on the fly, you can just pull in a NuGet package and you can do calls to this REST API through a very convenient, fluent interface. Or even another way, through C# that we're probably going to see in a little bit under an hour. But the thing that I want to explore with you is using ARM templates. So let's do that. Unless there are any questions so far, because I know I've speeded through a little bit. This is a small group, just interject. And I see people nodding, so this is probably a lot of repetition. So there are a number. So what we're going to do is we're going to author an ARM template. And ARM templates are written in JSON. So I'm just opening up a new file in Visual Studio Code. Not necessarily my editor of choice, honestly. However, this is by far the best editor for JSON, for ARM templates nowadays. So I'm just going to save this file as demo.json. And I've installed the extension for ARM templates. So I'm going to write ARM ! And I will get the JSON for an ARM template. And I will go through all these things slowly later on, but I just want to quickly show you how easy it is to, for example, create a storage account. Because what I can do now is type ARM-storage. I didn't have time to sacrifice to the demo guts, but it works. this is all the JSON needed for defining a storage account. And as you can see, this editor is very, very powerful, because I can also do things like this. And now I have defined a SQL server. And like I said, on the SQL server, we can have databases. Which is a thing that I would expect here right now. Oh, it's called DB. This is the experience for authoring ARM templates. Now let's quickly jump back to the slides and go through the different things and see what they mean. So this is the structure of an ARM template. It has a schema, content version, parameters, variables, resources, and outputs. So the first thing, let's start with the first thing just because we can. The bulk of the template is resources. This is a description of the resources that I need. And every object should have a type which is actually a reference to a resource provider / the name of a resource type. And if we're next up, it must have a name. Thirdly, it must have an API version. And fourthly, it must have a location. Probably things like West Europe, West US. And all the other properties are the properties that come from the JSON for the specific resource type that we have seen before. Now going back to what we know about this URL and calling it, we can quickly see how these three things are used to build up the identity, the URL of the resource. So that hopefully helps to make sense of these three properties on all these JSON objects. Now another thing that you might notice here is that I'm using this notation with square brackets, and then in between I'm kind of calling into a function. So there are a lot of built-in functions within the Azure Resource Manager. One of them, for example, is resource group. This will give me an object with a number of properties describing the resource group that I'm currently deploying to. So what this will do, it will look up my resource group, find its location, for example West Europe, and will reuse that location also for the location of the resource. The function variables kind of does what it says. It looks up a variable for within the template. Now these resources are the bulk, but remember we had these parameters and variables before them. So let's look at those first, or next. Parameters are things that I can declare at the top of my template to allow the executor of the template to pass things in just before the template is executed. So let's say I want to create a storage account, but I want to allow somebody to specify the name. I declare a parameter, I call it storage account, and then I later on reuse that parameter as the name of the resource. The syntax is like this. It's an object. Every key is one parameter. That again is an object. First I specify a type, things like string, int, array, object that you would expect, but also secure string and secure objects are just strings and objects, but where Azure guarantees that the values will be scrubbed from any type of logging, which is really cool when you're working with passwords. And finally there are things like minimum length, maximum length, but also min value and max value, for example, when working with integers. Now, kind of comparable, but definitely not the same, are variables. Well, we can pass parameters in from the outside when we're going to deploy a template. For variables, they're going to remain fixed within the template. So they are kind of the place where we put values that we want to reuse. So let's say I want to create the name of a storage account and I want to use it 3 times. Instead of repeating that expression, I can put it one time in variables and then reuse it a number of times later on. Now a construct that you see a lot of times is that people are going to pick the same template and first deploy it to a test environment and then to a production environment. And this is where we can use the combination of parameters and variables in a smart way to derive the names of all our resources. So one of the things, so what you often see is that they have just one parameter to the whole template, which is called environment. And I'm going to specify that it has to be either test or production. And then in the variable section, I'm going to derive all the names for all my resources from that one input parameter. So I know that, for example, my storage account name has to be my storage, probably a dash. No, that's actually forbidden in storage accounts. So my storage, I hear a little bit of pain. So my storage and then the name of the environment. And this way I get consistent naming between test and production, which is really cool for some people. Then we get the resources. We've seen those before. Now, here again, we can use SUP Resources. Now, what you will notice here is that the type will be extended with another slash and then the name of the SUP resource. It means that the name is also going to be extended by a slash and the name of the SUP resource. And these two things will just be inserted here and here to generate the URL again. It also means that there is a rule that says that the number of slashes in type has to equal the number of slashes in name plus 1. And you might get a lot of errors that actually go back to this problem. And then the error will be that the number of segments in the type in the name do not match. Now, if a resource is a SUP resource, that SUP resource can only be created once the parent resource is created. So there is another construct that we can use. It's called depends on, and it declares the dependency from the child upon the parent, and this will ensure that the child will only get started creating once the parent is created. Now, this depends on we can use in other relations as well. So if in my app settings I'm going to refer back to a storage account, it's not a nested resource, but I can use the depends on declaration. For parent-child relations, it's mandatory, and you might be wondering, why does ARM require you to specify it while it can deduce parent-child relations? I simply don't know, but it can deduce it correctly, because you will definitely get an error saying this is a parent-child relation, so you have to specify a depends on relation. So maybe that's fixed in other abstractions on top of ARM templates. Now, the fourth thing that we saw in the, I don't know honestly, but we will learn later on, I hope. The fourth section is called outputs. Remember that we could pass parameters in to use in the ARM template. If later on you're going to use templates from a pipeline, it is very likely that you're going to chain another task after the deployment of your infrastructure. I don't know, the deployment of your code, for example. Now, if you're going to deploy the code, it has to go somewhere, for example, to the app service. And to do that, you're going to need the name of the app service. Now, if the app service name was generated within the template, you need a way to return it. So that's where the output section is for. So here I am returning the name of my storage account back to the caller or the executioner of this template. Now, I already quickly touched upon the subject of functions. There are a lot of functions that you can use within ARM templates, parameters and variables. They're kind of self-explanatory. Then we have resource group and subscription. They will return objects with a number of properties from the resource group or the subscription. We have resource ID, which is a function that we can give the name of a resource provider and a reference to a resource, and then it will construct the URL and it will make sure there are slashes but not two slashes, etc. We have concat, simply string concatenation. We have list keys. Now, that's an interesting one. This is a function that I can call on the URL of, for example, a storage account, a maps account, a cognitive services account, and it will return me an object that contains the primary and the secondary key for that resource. Now, if I can use my ARM template, sorry, my lens is really hurted after this shower. If I can reference these secrets within my ARM template, I can automatically inject them into the app settings or a key fold without ever touching them, holding them in my hands, with the risk of losing them. So that's really cool. And there are many, many more. I think close to 100. And just as with the properties, it might be a bit overwhelming, all these functions, but there's a really good reference for those as well. Now, remember we had the declaration of these parameters at the start of our template. If you specify a lot of parameters, you might want to create two sets of parameter values, for example, one for your test environment and one for your production environment. So what you can do is, besides your template, you create just parameter files that contain all the values for deployment to that environment. And they take a shape like this. A JSON object, schema content version, and then parameters object where you specify the name of the parameter as the value is an object within which you nest a value which contains the actual value. Might feel like a little bit of overkill, but the reason is there is another way of specifying the value for a parameter, and that's by referencing a key vault. We cannot use this syntax for passwords. We cannot put passwords into source control or in a plain text file on our computer. We can put them, however, in a Azure key vault. And once they are in that key vault, we can reference them from the parameter file. We do that by putting in a much more elaborate object, which has one property called reference. The value is another object. I reference the key vault by its ID. Now, hopefully, by now, this URL looks a little bit similar to the URLs you know for finding resources. And then I have to specify the name of the secret. And with that being said, first of all, the machine finally turns off. And secondly, let's step away from JSON for a little bit. Are there any questions right now? We'll do a little bit of Q&A, free format stuff.
Do the CLI and the UI and the templates offer completely the same configuration options?
No, because the REST API and ARM templates, yes, because ARM templates will just translate to URLs and JSON objects. However, the CLI and PowerShell and SDKs and the portal are abstractions built on top of it. So they might not be lacking, but they are definitely not ahead of the ARM REST API. Often, however, they are lagging a little bit. And sometimes there are capabilities that are not present in CLI or PowerShell or SDKs for quite a long period of time. Now I think this is getting better and better, so coverage is almost complete for all of them. But a couple of months ago I spoke to somebody who was like working with really cutting edge stuff. So for his provisioning he started with ARM templates and then with PowerShell, and then he found out that there were a few things missing. So he had to pull in the CLI for just a few things. And then something was missing in CLI and PowerShell. And then finally he had to pull in just a REST client and call the API directly. So there is a risk there.
So better start right here then.
Yeah, with ARM templates, or let me be friendly, an abstraction on top of ARM templates, or at least the REST API.
I think it can be the other way around though. Like there are some features supported by CLI that go like into browse, not broad. I think there were cases like that, I don't remember.
Is it according to the preview version of the Azure Manager?
Might be, but there are now also things that are in the Azure CLI that are not strictly Azure anymore, because I think there are, for a number of things, they are now actually calling into the Microsoft graph or the Azure Active Directory graph. So they are on par mostly with the ARM REST API, but they're now also building other functionalities on top of other APIs. Yes. But I do not top of mind know which one precisely. Do we have any other questions? Next to this thing that I quickly drew up, I already prepared a very simple other ARM template that I wanted to show you. So before we start, if there are people with a photographic memory, or they have a memory that's good enough to remember this, do not worry. I will remove this later on. So what I've created an ARM template, and it doesn't take any parameters. It has one variable, which is the name of a SQL server I wanted to create. So just before we started, I made sure this name was unique, but let's make very sure. In the resources section of my template, I specify the creation of an Azure SQL server. So the name of that server is going to be referencing back to the variable. The type is Microsoft.SQL/servers. The location is going to be derived from the resource group. API version, it doesn't take any dependencies, so just let's remove that. Then I have to specify the login and the infamous password. Don't do this again. It doesn't hurt to point that out a number of times that you know that you shouldn't do it in the real world. And on that server I want two more resources. The first one is a firewall rule that whitelists all the IP addresses within Azure to be able to access the database. And the second one is an actual database. So we've talked a lot about this JSON, and I hope you can follow me along, but now you might be wondering, how do I get the thing in Azure? So here in PowerShell, I already have connected to one of my subscriptions by executing connect AZ account. And now I select one of my subscriptions. Go 4G, go 4G. There we go. And let's create a new resource group in Azure. And let's give it a, I thought it was called name. SQL demo. No, not one that already exists. Now I have to specify location, West Europe. And this should take just a second. Now what I can do is I can create a new AZ resource group deployment. I specify the name of the resource group, which is just SQL demo, and then I specify my template, which is this thing /Azure deploy.json. This will take roughly 2 minutes, and after those 2 minutes my SQL server should be there. So while we wait, it is good to know that the deployment that I'm doing now is also a resource in itself. So it's a thing that I can find within Azure. So if I go into the portal and I say who I am, and I go to my list of resource groups and the SQL demo, we can see there is a deployment going on of an ARM template. I can see the name of the deployment. I can override this actually, but by default it's the name of the file. And I can see that this is deploying right now. And I can see that this is now creating a server. Remember that we had two SUP resources. It is going to wait with trying to create those until the server creation has completed. So I can refresh this. Sometimes it's really quick. There we go. Now the server is created, and on that server the firewall rule is created, and we now see that the database is also being created. This used to be painfully slow. Now it's just annoying slow. But I guess I'm a child of my time, because this, if you show this to an IT operator that has been creating SQL databases by hand on an installation in the basement on bare metal, his mind will be blown. So I know I'm a spoiled brat. Sorry?
They start using excuses not to use it.
That,
This is.
oh, that might be.
Which pricing tier was that?
Sorry?
Which pricing tier? What's the size of the database?
Of this database, this is empty, right? Because it's.
No, I mean the SKU provision capacity of this SQL server.
I think this is a basic, because.
Depends on like the provisioning time. Depends on the size.
As far as
the big one used to be very slow.
As far as I know, there is no official statement. I haven't really experienced any differences when it comes to things from the DTU based provisioning model. I have very limited experience with the vCore based model, and what I do know is once you start provisioning managed instances, they are going to be slower. Yeah, this is basically how easy it is to deploy an ARM template from your local computer. However, you might be wondering, is this a very good development practice when I am working in a team, create the infrastructure, change the infrastructure a bit and deploy from my local machine? Well, I think we all know the answer, and the answer is no. So as an alternative, what you can do these kind of things from Azure DevOps. So I have a repository where I have an ARM template, which is this. So this is governed by pull requests, policies, peer review, all these kind of things, and the corresponding parameter files. Whenever there is a change in this repository, a pipeline kicks in, it compiles my code, it runs my unit tests, it does all these fantastic things to ensure that I can be very sure that I can deploy the code. But one of the things that it also does, it also creates a second artifact next to the binaries that I want to deploy. It creates an artifact with the JSON files, the templates and the parameter files. So I copy the files to a staging directory and I wrap them up as a build artifact. Now that thing I can pull up again in a release together with my binaries, and then I can build a deployment pipeline a little bit like this. The first step is a deployment of my infrastructure. So it might be there is no infrastructure at all at the start. It might be that it's all there except for this new database that I just added. It might be that I just changed an app setting. Anyhow, it's going to be deployed. And once that is done, I call into another task called ARM outputs. This goes back into Azure and it refetches all the outputs of the latest deployment. And it makes them available as variables in this stage of my deployment pipeline. And then I do things that we know from continuous deployment. I deploy my code, I swap slots, or I change stuff in the routing table or in the load balancer. And that's a pipeline that includes infrastructure as code. And by extension, if we go back to this pipeline, another thing that you can see here is that I kind of have these two environments, stages we have to call them now, test and production, we all know. And whenever a merge to master completes and a build artifact is built, it goes to this test environment automatically. But I have also created this stage. This stage that will trigger whenever a build completes from a pull request. And what this will do, first, it will deploy my ARM template again. But it will not do that to, that's so not what I intended. It will not do that to a fixed resource group. It will do that to a resource group with a generated name, so a non-existent resource group. And it will create a complete new instance of my complete infrastructure. Then I do my deployment, just like I used to. Then I'm going to run a very, very extensive test set, basically a get on a URL. And then I tear the whole thing down again. Now if all this succeeds, within 10 minutes the environment is spun up, tests are executed, and everything is teared down. However, when something fails halfway, everything is going to remain there. I can investigate the error and tear it down whenever I'm done. And I'm so sure that this works. Actually, I'm not really sure because I just moved everything over to a new subscription and connected everything up again. But it doesn't really matter. I am going to do a change in this repository. So I'm going to create a new branch. I'm going to open it up, open a very important file, make an important change, commit that change, and create a pull request. Now this will trigger a build and then a release, and it will actually deploy things into Azure. Things that will cost me money. Sorry for the mic. things that will cost me money. But we're not going to look at that because I'm very confident they will disappear in 20 minutes. All right. One of the things that this allows us to do, this management of our resources, is that we can do one of the things that operators have wanted for years, and they have forced us to do for years, and that is by working without access to production. And that's actually quite feasible now. What I can do is I can write a test environment to an existing resource group and say, next to my pipeline, the team has access to that environment as well. I can create an acceptance environment where the team just has read access to check if things are working correctly, and if not, it cannot just quickly fix them and change them. It has to start in Git again and has to follow an automated process to get that change to acceptance. And once we are very, very confident that everything is correct in acceptance, we can deploy to production where we cannot see anything, but we can be very confident that it works there as well. Sometimes reality bites us in the ass, so do make sure that you have a way for getting access whenever you need it. Something like a calamiteiten account or a break class account. Now, what I've shown you here is very simple, the basics, but hopefully this is enough to get you started at home. But do know there are more advanced things possible as well. For example, you have seen a deployment of a template to a resource group to create resources. You can also deploy a template to a subscription to create resource groups. And you can even deploy a template to a management group to create subscriptions and role assignments and policies and all kinds of sexy things. Another thing that you can do is you can use a template to deploy another template. So if you have 5 application components and they all have an ARM template, you can create one ARM template that triggers those 5 ARM templates. Not always the best thing to do, but it's possible. Now another thing that's good to know is that you don't have to write everything from scratch. So just if you're thinking, well, we have this existing infrastructure and it has quite a lot of components, and I do not want to start writing JSON from scratch, because honestly, who likes writing JSON, especially very, very large JSON files? So one of the things that you can do is you can just open any resource group and go to a thing called export template, and it will actually give you a template for the things as they are right now. So you can just start with the situation as is and start applying continuous deployment from there. Good to know, this will also include all the default parameters. So maybe this very, 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 very large file of JSON, you can trim that down to what you really, really need. But it's a good starting point. And next to that, there is also the Resource Explorer in Azure, where you can browse your subscription as we're a very, very big JSON document. There you can find properties and things as well if you want to reverse engineer them. Well, I want to conclude with something very sexy. I think we're developers, so we all love to be regulated and try and be compliant and follow the rules, etc. So one thing you might be familiar with is Azure Policy. Who is familiar with Azure Policy? Okay, so a number of people. What Azure Policy allows you to do is to write JSON that says that if a certain condition is found in a resource or a new resource deployment, to take a certain action. To make that a little bit less fake, sorry, an Azure Policy is an Azure resource, as we can see right here, that specifies a policy rule. And if we zoom in that policy rule, we will see that I can specify a condition. For example, whenever the type of a resource is Microsoft or Classic Storage / storage account. These are V1 storage accounts. They are nasty, they are old, and they should not be created anymore. But if somebody does this, I want to audit that. I want to put that resource on the naughty list. But instead of audit, I can also write deny, which just means that when somebody tries to create such a thing, in the portal it's going to say denied. If you're going to deploy an ARM template, it's going to fail. It will. And there's the third option, which is actually deploy if not exists. And then it allows you to point to another template. So you can trigger a new deployment whenever a certain condition is met. And that's the final thing that I wanted to show you. Because what I have right here is a very simple policy. Let's imagine we have a scenario where we want people to create databases as many as they like, but there is one rule, and that rule is that you have to whitelist the IP address of headquarters so that some tool can connect to the database and do stuff. Now I can write a policy that says whenever I deploy a resource of type Microsoft.SQL, deploy if not exists, and then I'm going to check if there is a firewall rule on that server which has a whitelisting for that IP address, and if it doesn't exist, I'm going to deploy a complete new ARM template. And this is an ARM template that contains a firewall rule. I'm not going to dive into the JSON because probably by now you're JSON blind, but trust me that it's there. And to prove to you that it works, remember this SQL server that we deployed a little bit ago? If I now go back to resource groups and then to my SQL demo, oh not that one, that one, and my deployments, I was very sure that we would see this. So let's take the already finished cake out of the oven, because what I wanted to show you is this. Oh, sorry, Zoom doesn't work. I have done a deployment of a SQL server, and a few minutes later, 6 minutes actually, a second deployment was triggered. So this SQL server that I deployed did not have the required firewall rule. The policy detected that, and then it deployed another template that actually created a firewall rule. Yes?
Why would you like to do this? Why don't you just include it in the first template?
Yes, so you're completely correct. As a developer, if I need something, I'm going to include it in my deployments. But now let's say you are an IT operator for 25 resource groups that are handed out to 25 different development teams, and you say, yeah, that's all good and well, but whenever somebody tries to deploy a storage account that does not have HTTPS only set to true, I'm going to deny that.
Okay, but for example, like not deny, not audit, but third option, deploy.
One of the things that you can do is tags. Let's say you have a rule that every resource should be tagged with a cost center. And whenever somebody does a deployment that does not contain a cost center, you're going to specify a cost center unknown. I don't know. It's one possibility. I am not a big fan of this. I'm a fan of audit and deny, not of deploy if not exists. Why? If something does something that is not compliant and not correct, just slap them and make sure that they fix it. But that's a matter of opinion.
Could we deploy completely your new subscription, creating subscription, resource groups, and just
I am now working with a client where we are going to from startup to scale up. So they are going to do this. They are going to create a template for the management group, which contains other management groups, which contains subscriptions, which contain role assignments, policies. And the one thing that I'm not certain about is if you can create subscriptions this way and under which conditions. And the reason for that is the subscription is linked to the credit card. So there might be some reasons why this thing does not work or does not work always. I simply haven't tried it.
You look at build for the subscription. So from subscription to subscription, all the transfer that is in the data center will be built if you use the multiple subscriptions.
So, sorry,
if you have two subscriptions, you have data transfer between them, which is normally in the same data center. Normally you don't pay for that because it's all in the same subscription. If you have two subscriptions, you will pay for a data transfer. So if you do that at large, then you need to keep in mind that you might pay a bit more for data transfer.
Oh, so you mean if you have very fine-grained subscriptions and you're going to have a lot of data transfer between them, you're going to be charged for the data transfer?
Which normally is free.
Okay. Today I learned. Thank you. Are there any other questions? Okay, now I'm going to quickly check something because I am Dutch. By the way, Fanny, welcome to the Dutch world. I just read that your bike was stolen. As you can see, I have no more resource group called pull. So this thing was created, the test run, and it was removed again, and I'm not paying for it. Now, a word of caution. If you are creating resources that are built by the hour, and they are very expensive often if they are charged by the hour, and you do this 10 times an hour, you're going to incur 10 hours worth of charge every hour. So if the resource costs you, I don't know, 10K a month, you're going to end up with a bill of 100K a month. So this approach is really cool when you're using real paper use things like functions or event grid. But if you're using pre-provisioned high-performance resources, this might get expensive. Just a word of caution.
They could be an issue if it's related to DNS registration. For example, front door. If you delete front door and recreate front door, it gets stuck because previous is not deleted yet, so new one can be created yet.
If you do this in a at a very high speed, especially with complex things like indeed front door or traffic manager, you might get weird things. However, ARM is supposed to guarantee that once it says it's deleted, it is really deleted. And one resource provider is better than another.
A few times it was like it stuck for 2 days, but it was some issue. It's not usual.
And it's software, right? And what do we know of software? It is a race to get it out of the door, and sometimes there might be still mistakes in there. So when a service matures, the likelihood of things like these occurring gets lower in general, but it might happen.
We got this even with the resource group. So when you create a resource group, it says created, and then you try to create something there, it says that the resource group doesn't exist yet.
Now, I think there has been a change around Ignite last year where they have added very aggressive caching in a number of places.
Yeah, I believe it was around Ignite last year.
And I think the portal experience has gotten much snappier around that time, but when you create a resource group, it might take up to 1 or 2 minutes before it actually shows up in the list when you hit refresh. It's a thing that I reported actually back to the team, but I reckon more people will complain about it over time. But I've seen it with resource group creation especially. And of course, I encourage you all to try that at home. My Twitter and LinkedIn are on there. Let me relieve you of that animation. And if there are any final questions, now's the time, or otherwise I will yield the floor to Michael. Kak. I give up, sorry. Michael. Michiel. Michael.
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 Yes.
Michael. Thank you.